Well, this cabinet talks to Home Assistant, but I only wanted to take my printer off the floor. What happened here? Since I got my 3D printer back in July of 2024, it has been sitting on the floor, and it kind of bothered me. Not only was annoying to reach and maintain the printer, but it was also blocking that corner where I store some material for projects. At first, I started looking into pre-made solutions. A good candidate would have been a 2x1 calyx from IKEA. Since I already have two calyx units here, it wouldn't be out of place. But that idea had two problems. Number one, the printer is slightly deeper than the calyx unit. I'd need to attach a wooden top deep enough for the printer. Second, while the top part would be easier to access, one of the cubes would be completely blocked by the other calyx. Building it without the middle shelf wouldn't be ideal, as it could compromise the structure of the unit, since it's not solid wood and it's designed to have that shelf. So I started drawing. No, not that drawing. I took some measurements of the space I had to work with, the printer's dimensions, and I concluded that, yeah, I'm basically building a calyx 2x1, but in solid wood with L brackets to reinforce the structure. I got a panel of pine wood of 200 by 40 by 18 millimeters from my local lumber store and got to work. Luckily, I was able to get two cuts done at the store, so the top and bottom I perfectly cut and square. I only needed to cut the sides, one from the same board and the other from a leftover piece from another project. Then came everyone's favorite task, sanding. That basically took an entire day. Every time I went outside and turned on the sander, it started raining. To match the rest of the furniture in this tiny corner, I painted it black, but with a white top. The first print for this 3D printer project had to be some painting pyramids. I was a bit skeptical at first, but they worked great. I dry fitted the cabinet, everything seemed fine, then glued and screwed everything and added the L brackets. I think the white top really looks great. After a day or two, it was time to test how sturdy it was with the print. Everything seemed fine, except the corner was still a mess, and I thought I could improve the lighting of the printer. So I started drawing. Nope. Basically designed a simple squarish structure to sit on top of the printer, where I could mount LEDs. I've seen a couple of mods where the LEDs are placed below the glass, even connected to the printer, but I didn't like the look of that, and I had other plans for this light. I printed it in 4 parts and glued them together, then cut 4 LED strips and soldered them. After gluing the LEDs to the printed base, I had a working light. Sure, the dark glass makes it a bit dimmer than it would be if the LEDs were underneath it, but for now it's already a big improvement from my previous setup. With that sorted out, I started thinking, wouldn't it be great to control the light through Home Assistant and of course automate it to turn on and off when the printer is printing? And whenever I start to think Home Assistant and automations, I start to think RGB. Wouldn't it be cool to have a progress bar and indicator like the new Bamboo H2D? Well, I don't have the money or space for a machine like that, but that tiny little feature, not highly useful but highly cool, yeah, I think I can add that to my setup. And that, my friends, started a 2-month side quest. First, deciding what I need to make it work. An ESP32, yes. An addressable RGB strip, yes. The white LEDs? Yes. A way to control the on-off state and the brightness of the white LEDs? Yes. Power supplies? Also yes. It's a very simple circuit for this project. To connect it to Home Assistant, this time I decided to experiment with ESPHome, and that was not an easy task. From board connecting issues to just code issues, random corrupted data, all on top of having very limited time to work on this project, but with some perseverance, a lot of interneting and redditing, and some ChatGPTing, I got the ESP to connect and the LEDs to work. Later on, I'll show you the ESP configuration for this board, as well as the automations I'm running. I could have continued by soldering the components for the control board onto a prototype board, but instead I embarked on another side quest, designing my first PCB for myself and my home. Back in university, I designed a couple of boards for power amplifiers, but I never got a chance to make something to use at home, or just to keep with me. This project felt like the perfect entryway to custom PCB design. It's a very simple circuit with just a few components to solder, and getting PCBs is actually pretty inexpensive these days. Of course, I used free CAD software, no more university license for me. To my surprise, KiCad was super straightforward. I followed a single tutorial and was basically able to design the whole board. I was so happy with the results that I didn't notice my tiny mistake. I'll tell you later on and you can judge me then. Or judge me now, I'm still judging myself to this moment. After the design was done, I exported the Gerber and drill files and had all I need to get the PCBs manufactured. And that's when I have to thank PCBWay that are very kindly sponsoring this project. I used PCBWay's website to upload my Gerber files and got an instant quote for the boards. Selected all the settings that seem right. Note here from a completely noob to PCB manufacturing. At uni, I only had to select the substrate, and that was it. No customization. But still, PCB's website made it super easy thanks to those question mark buttons that explain everything. The whole process was really effortless, so much so that I'm already pre-planning my second board. From the moment I placed the order until it arrived at my door, it took 5 days. 5 days. I had planned to work on the automations while the boards were in production, but I didn't even start. They managed to do all this, plus shipping to the other side of the world, faster than I could find free time to work on this project. Wow. So if you are considering designing your own board, check out PCB's Way website through the link in the description. Until the end of October, you can even get your board in this beautiful purple solder mask for no additional cost. And it doesn't even need to be a PCB. They also provide a lot of services like CNC machining, 3D printing with a variety of filaments, sheet metal fabrication, injection molding, and when you upload your files, you get an instant quote, so you know right away how much production and shipping will cost. I highly recommend. It was super easy, insanely fast, and when the PCBs arrived, I was so happy. They looked so good. Definitely so much better than any board I ever did. Until I noticed ESP23? What a rookie mistake. I really wanted to punch myself, but the PCBs looked so good. Oh, lesson learned, I guess. Always recheck your labels, especially the ones that will be visible and will stare at you forever. Other than my stupid mistake, the boards look so good. Thank you so much PCBWay for all the amazing work. I started soldering the components to the board, beginning with the shorter ones. I'll spare you the pain of watching me solder everything with this hook that I once called a soldering iron. I definitely need to get a new one. Before soldering the ESP32, I wanted to make sure all the firmware and automations were working properly. Of course, another long side quest. If you would like to do something similar, here's a rundown of what I used and did. Number 1, Home Assistant to gather all the information and execute automations. Number 2, ESPHome Builder in Home Assistant. This allows us to easily create and modify the YAML configuration for the ESP32. And number 3, in my case, the Bambu Lab integration, as my printer is a Bambu Lab P1S, but there are integrations for other printers of different brands. And this gives us access to things like print progress and print status that will be used for the automations. The YAML configuration I used to set up everything on the ESP32 side was this. A few things to note here. I configured the RGB strip using NeoPixel Bus platform, specifying the type, variant, pin of the ESP32 it's connected to, number of LEDs, the restore mode and method. As for the white LED strip, I used the LEDC output component, which exposes a LEDC PWM channel of the ESP32 as an output component. To be able to change the number of active LEDs, I use an API service called Addressable Set that basically exposes the range to be used in the automation. To help me with the progress bar automation, I used an helper, very appropriately. It's an input number helper that is used to store the number of active LEDs. And here are the automations to control the lights. The first one, very simple, that uses the print status change as a trigger, and a set of actions for each status. For example, prepare, it turns the RGB LEDs blue, failed, turns them red, not good, we don't want that. For running, it turns on the white LED strip, For finish, it turns off the white LED strip, and for offline, it turns both lights off. For the progress bar, it is triggered by print progress change, and it does two things. Well, three. First, it updates the active LEDs helper. Then it performs the addressable set action, where we set the range for the active LEDs from 0 to that value, the one stored in active LEDs helper, turning on green, and then another addressable set from active LEDs until the end of the strip with all colors off. That is probably a better and much more clever way of doing this, but with all my testing, this was the way it actually worked. I can't guarantee this will work right away for you, but at least it's a starting point. To enclose the circuit and protect it a little bit, I designed a box with a lot of ventilation. Printed it in white to match the top panel. Well, I had to print another because the fit was too tight. And the project was pretty much... I still need to fix this mess. Ended up cleaning a lot more than this corner, even moved my router. And I'm still tackling every drawer in the setup. Now my printer has a home. It's super easy to access, the filament is stored underneath it. Let's forget the two boxes I have under my desk. And I have lights that I can control and show the status of the print. I love this project. At first it seemed quite easy and straightforward, but I had to learn and think a lot thanks to it. I hope you enjoyed following along this, and I hope it inspired you to do something similar. And consider subscribing for more DIY 3D printing and home assistant projects. And once again, thank you so much PCBWay for sponsoring this project. Definitely check them out through the link in the description. And until next time, bye!